Greetings and welcome to Make Programming Fun Again. My name is Karol Moroz, and in today's video I'm going to show you how to deploy a web application built in Golang to a $5 VPS running FreeBSD. I will be using a tool called Ansible to automate tasks such as installing and configuring software. I will also be using a web server called Caddy to serve the website over HTTPS with an automatically renewing TLS certificate. All source code shown in this video is available on GitHub here, and I will put links to these repositories in the video description. Now you may ask me, why FreeBSD? Why wouldn't I just pick a random Linux-based operating system like Debian or Ubuntu? And the answer is because I can. The whole project is basically an over-engineered Google form like this, and there is no reason it has to be a website at all. But I built it as a website because I wanted to, because I enjoy it, and because by painfully over-engineering projects you can learn a lot of things. And I believe these are the values that I stand for. Okay, so regarding what this project is, the project I will be showing you in this video is a website. And the reason this website exists is because a few days ago, somebody in the comments on YouTube asked me to create a Discord server. And I thought, well, it's a great idea, but I don't think it's going to work out if there is nobody using the Discord server. So I created this website so I can sign up for the waiting list. And then once we have 100 people sign up, you're going to get a notification and we will create a Discord server. I'm going to quickly go over the technical requirements. So I deployed this on a FreeBSD based VPS. It's running on Vulture in Tokyo. The reason I picked Tokyo is because I live in Taiwan and Tokyo is the geographically nearest data center. And the reason I picked FreeBSD is because I can, and because I did not want to pick the easy option. But actually a lot of this advice will be applicable to Linux-based operating systems as well. If you need to pick one, you can just pick like Ubuntu server or Debian. I think Debian is better, but they are basically the same. And then I had to set up a DNS record, more specifically an A-type DNS record, and this means that whenever you reach to discord.moros.dev, you're going to be able to resolve to this IP address. Also, the website itself is going to be hosted at discord.moros.dev. So in order to deploy this using Ansible, I created a repository to store some scripts. And some of these scripts are responsible for configuring the machine before we do the actual deployment. And some of these are responsible for the actual deployment. I'm only going to go over the scripts briefly because it took me 2 days to write these scripts. I think you're going to need a lot of knowledge related to Unix-based operating systems to fully understand this. But basically, I have a script called sci.yaml. It's written in YAML, which is like a bit of like a human and easier to write JSON. There are scripts in here. There are like groups of tasks which do things like installing software, setting up users with permissions. I created a user for the application to run. I created a user for deployments, and I created a user for the Caddy web server to run. And the good thing about Ansible is that you don't really write things like create a user. No, you write, I want this user to exist, and if you run the script over and over again, and this user already exists, it will just not do anything. Also, so basically these two sections of the file are pretty easy to understand. Then these are FreeBSD specific rules that allow the a Caddy user to listen on ports 80 and on port 443. I specifically picked this user ID, so that I think it's basically meaningful, but it doesn't really matter. I just wanted to be able to point to this Caddy user by its user ID, and 443 just happens to be the default port for HTTPS. And then these are things like allowing the wheel group to perform privileged actions without password. And this is very nice. This basically just downloads my public SSH keys from GitHub and adds them for the given user. And it's like if they already exist, it will not do anything, which I think is very nice. These are port permissions. Then there are repositories. There are directories. And in this situation, I'm going to quickly sign into, I'm going to connect to this machine. What was the IP address again? This is the IP address. I'm connecting here. And the application itself lives at user local lib server. And this is the file where basically almost everything related to this application lives. And I'm going to, can I get color? No, I cannot. Like this, okay. So current is going to be a symbolic link to the latest release. And now instead of releases, we're going to get the 3 most recent releases. This is related to the way the deployment script works. Then this file, discord.env, it contains environment variables. And right now, all of these environment variables are public, so I can safely show it to you. But in the future, if this contains any secrets like a secret keybase or anything that should not be released to the public, I will not show it to you. And then the prod.db is the production database in SQLite format, because I used SQLite for sake of simplicity. And what else? Okay, this is also specific to this application. So for database migrations, I use a tool called Goose, which is very good. But I don't think they provide binaries for FreeBSD on their website. So no, they only have macOS, Linux, and Windows. So the thing I did is they do not provide binaries, but Goose is written in Go, and FreeBSD supports Go. So I can just compile it, right? So this part of a script, it only runs if Goose is not installed on the target system yet. And then it runs a script. It's basically a simple script that clones the Goose repository. It downloads dependencies and then compiles a very lean binary of Goose. And then we can just upload it to the remote machine. And in here you can see that it will even run correctly if the remote machine is running has an ARM CPU. Ansible is very powerful, and I'm very happy to have learned it. And the The next part is the configuration for Caddy. Now Caddy, it's a very smart tool. It's basically like Nginx, but with like 1/20 of the configuration. So when you actually look at the Caddy file, the config user local etc. Caddy file. So this is the whole configuration I need to run a reverse proxy. I only need to specify a domain name and the reverse proxy location. And this in Nginx, I think it would correspond to like 60 lines of code. And surely enough, we actually get a proper valid certificate. So less configuration, less hassle. And the thing with Caddy is that even though they do even though the GitHub repository does provide binaries for FreeBSD, they only provide binaries and they do not provide any scripts for deployment, any scripts to run Caddy in a supervised environment. So I think what I had to do was sudo neovim etc rc.d caddy. This is an RCD script. This is the way services are started and stopped on FreeBSD. It's basically like a glorified shell script, but it works somehow. I wouldn't really call it convenient compared to systemd, but you know, some people don't like systemd. So this part of a script basically downloads a Caddy release from GitHub, then it uploads it, then it unpacks it to user local bin Caddy, and then it generates an RCD script. So the exact script I showed you on the remote server, it was created by Ansible. Then you can tell Ansible to create files with templates and whatever, with specific owners, with specific owning users, groups, and file modes. So this is 0644, which corresponds to, you know, the flags. If we see ls-las color user local etc. Caddy file, and we see we specified it should be owned by the user root and group wheel, and surely enough it is owned by user root and group wheel, and it is writable by the owner and only readable by the group and others. So all of this can be specified in such a nice declarative way. Now this setting, it basically just means that we want to enable the newly created service, and this means that Ansible will ensure the service is started. And then the last part of the setup script is creating an RCD script for the application itself, because it also needs to be supervised. And this one was a bit tricky, but maybe it's just, you know, a skill issue. I think it's at Discord. This is also just a glorified shell script, but in this file I did quite a bit more than in the case of Caddy, because we need to do things like loading the environment variables, and then we have to specify the PID file. The PID file is a file where the supervisor is going to store the process ID of the service, and things like login, like tag in the logs, and the user the application is going to run as, and how often it should be restarted, and all of these. In this file we also run migrations, and so the nice thing at this point is that with this setup we can actually go and see the logs related to, like, the logs from this application. So if I access the website in this tab, we can see that we are getting logs for in real time, which I think is nice. And yep, so this is nice. And that's kind of all there is to this site.yaml script, the one that prepares the application for deployment. And then I have another script, and this script basically uses the infrastructure that I set up in the site.yaml file. And what we do here is we run make release in the actual project directory, and make release is basically just another glorified shell script. So what we do here is we compile styles, because I actually use Tailwind, and it compiles the server, but we compile it using the target operating system, which is going to be FreeBSD. So you may notice that I'm developing this on an ARM-based Mac. It's an M4. So this is an ARM-based CPU, and the remote system is using AMD 64, which is like Intel-based processors. So we want to compile it for FreeBSD and for the FreeBSD on AMD 64 combination. And then for every time we do a release, what we do is in releases, we create a directory with a timestamp of the deployment. And then the script uploads all the files, and from this release tarball, and places them in this target directory. Then it symlinks, it creates a symbolic link from the latest release to current, and then it just restarts the service. So, and then this part is, it makes sure that there are only at most 3 releases in this directory. So I can show you how it works in practice. So let's say I wanted to do something about write some more text on this website. So let's say I want to say that my personal website is at moros.dev, and a redesign is obviously long overdue. This is like nitpicking. So I modify the text here. Yep. And now in the infrastructure repository, I run the deployment script, and it basically does all the steps I just described. And at this point, as soon as it restarts the service, we can go to the website, and we will see that the text changed just like we modified it on the localhost. And now if we connect to the remote server, we will see that at user local lib server releases, there are still only 3 directories, and their timestamps are different from the last time. Okay, I think this is more or less all there is to it. As mentioned, all of the source code from this video is available on GitHub, and I will license it as BSD free, which means you can use it for your own projects. And the source code for this repository is also going to be open source on GitHub. So if you enjoyed this video, please like and subscribe. And if you want to join my Discord, you can also join the waiting list through this website. And I hope you learned something, and I will see you in the next video, which is going to happen in about 2 weeks, because I'm going to Malaysia tomorrow and I will be making travel videos instead. See you and goodbye.